Hi guys, today I have a very difficult task. This is the building G+4. Okay, the floor to floor height is 3.3 meter and the plan dimension is also given. Now my task is I have to find the type of foundation, raft or isolated, and also the area for that type of foundation. And the main thing is I cannot use any type of software. I have to do this by hand calculation only. Do you know how can I do it? Well, let's see. This is the plan area and the column to column distance is 3.5 meter in one direction and in another direction it is 4.5 meter. By the way, welcome to my channel. If you are a civil engineer, please subscribe it because here you will get videos on analysis, design and construction. So let's start. So this is the perspective view of the building. This is the front elevation and this is the side elevation and this is the plan view. Okay, to solve this without any software, first I will select a particular column from each side. Okay, so how I select the column? I will select the middle one. Why? This carry the maximum load. So if I design the foundation for this column, obviously it will be safe for another column also. So from front side, I select this column and I will select the area from which the load is coming to this column. Okay, here I have indicated in the plan also by this center line indicated in black color. So if the column to column distance is 4.5 meter in this direction, obviously the center to center distance of these two lines is also 4.5 meter. Again, from the side view, I again select another column and again the middle column. Why? You know the reason. And here in the plan, I have indicated that strip by this red center line. Okay, now can you see something special in this drawing, plan drawing? Well, let me tell you, the middle column, you can see this. Okay, the middle column carry the maximum load and you have already learned how I have got this. So if you design the foundation for this middle column, obviously this will be safe for each of the side column and also the corner column. Why? Because the tributary area for this column, I repeat, the tributary area for this column is maximum, and that's why the method I am using to calculate the foundation size is known as tributary area method. Okay, so this is the time to calculate the load coming on this particular column. From where? From this shaded area or the tributary zone. So you know already the plan dimension of this shaded area. In this direction this is 4.5 meter and in this direction this is 3.5 meter. Clear? You have already learned how I have got it. Now it's time to calculate your load. So before calculating the load, I will show you how this column looks like in elevation. So in elevation this column looks like this. How? This is the ground floor. Okay, this is the foundation which I have to design. This is the first floor, second floor, third floor, fourth floor, and this is the roof. Okay, so first I will calculate the load coming any particular floor on this column. Clear? So just consider this floor and I will calculate how much load is coming in this point. Then I will simply multiply this load which is coming to this point with the number of floor. So what are the different load coming to this point? By the way, for calculating with your hand without any software or for sizing the foundation initially, you may ignore the wind or earthquake load. Okay, so right now we will calculate first the dead load which is coming to this point and the live load which is coming to this point. So dead loads are coming from which point? Slab, then beam, then column, and if there is wall, brick wall, the load from brick wall is also coming to this point. Okay, so let's start with load in slab. In this point, this is the elevation and this is the slab. So what is the thickness of this slab? So just assume you will provide the thickness of slab as 125 mm or 0.125 meter. And what is the area of this slab? Again, go to the tributary area. For this column, you have to consider this shaded region. And what is the dimension of this area? 3.5 meter by 4.5 meter. So from that you will get the area of your slab as 15.75 meter square. So now assume the density of concrete. The slab is made from concrete. Okay, not only slab, for slab, beam, column, everything we will assume that density of the concrete is 25 kilonewton per meter cube. Now you have got the area and thickness. If you multiply with that the density of concrete, you will get the load which is coming from the slab for this particular zone. Okay, now calculate the load which is coming from your beam. For this column, say the beams are runs from this point to this point, this point to this point, and again from this column to this column, this column to this column. But within this zone you get only this to this point, and in this direction from this point to this point. Okay, so assume you will provide a beam of size this, breadth is 300 mm and depth is 500 mm. So what is the weight of this beam in this zone only? What is the length from this point to this point? Obviously 4.5, and in this direction it is 3.5. So you get the length as 8 meter. What is the cross-sectional area? Simply multiply the breadth and the depth. You will get 0.15 meter square. Again, just similar to the slab, calculate the volume, length into cross-section area, and then multiply this with the density of concrete, that is 25 kilonewton per meter cube. Okay, so you get the weight or the load for beam is 30 kilonewton. Now it is time for column. Okay, what is the length of the column? For this point, we can assume that the load of the column is coming from this point to this point, and you know the floor to floor area is, the floor to floor height is 3.3 meter. Okay, so obviously from this point to this point, as these are the midpoint between the floors, is also 3.3 meter. You got the length of the column as 3.3 meter. Now assume any size. Just assume 500 by 500 column you are going to provide. Okay, so in that case the cross section area is your 0.25 meter square. So what is the load coming from this column only for particular this length of column? Well, 3.3 meter is the length, this is the area. You got the volume and multiply this with your density of concrete 25. From that you get 20 kilonewton for column load. Now it's time to calculate the load for your brick wall. Okay, brick wall is similar to the calculation of beam, but in case of beam the depth was only this much. Okay, or the depth was 500 mm, but the floor to floor height is 3.3 meter from this point to this point. So for beam you have already taken 0.5 meter or 500 mm. So what is the remaining? The remaining is 3.3 minus 0.5 or 2.8 meter. So here the depth of your wall is 2.8 meter, and consider you are providing as internal wall. For internal wall our thickness is 125 mm. So you got the cross sectional area 0.125 into 3.3 minus 0.5 or 2.8 meter. What is the length? Just same as the beam or 8 meter. Now 8 into 0.35 means you got the volume, but here I have multiplied with 19. Why? Because as per Indian standard, the wall or the unit weight of the wall you can take as 19 kilonewton after finishing with plaster. Okay, so you for conservative you can take as 20 kilonewton also. So from that you got 53 kilonewton. So what is the total dead load coming? You have already got for wall, for column, for beam and for slab. It's time to calculate the load coming from live load. Well, for this lesson we will consider that the intensity of your live load is only 4 kilonewton per meter square. What is the tributary area? Just similar to the slab, your tributary area is 3.5 meter by 4.5 meter. If you multiply that area with this load intensity, you will get the total load which is coming from your live load. Here our live load is 63 kilonewton. Okay, so our load calculation is complete, and for each node or each floor how much load we have got. So live load as 63 kN and dead load, let's recap. For wall it was 53 kN, for column it was 20, beam 30, and for slab it was 49.2 kN. Just add them up. Okay, so after addition we got total dead load as 153 kN. So total load or live load plus dead load is coming as 216 kN, and this is for each floor. Now the question is, how much floor do we have? Okay, let's count one by one. Don't do any mistake. First one is your roof, second one fourth floor, third floor, second floor, first floor and ground floor. Okay, so total 6 number of floor we have to consider. You may ask that for roof floor we may take as half of the load because at the top there is no column. Okay, you may take, but during hand calculation you may ignore this type of detailing. Okay, so what is the total load coming as 1296 kN, 216 kN per each floor, and we have 6 floor, so total 1296 kN. So you have calculated load up to this point, but you have not considered the weight of the foundation yet. Why? Yes, you have to consider this weight also, because this is also going to transfer within the soil. So for that, we don't know right now what is the size of the foundation. We will simply assume the 10% of the total load just we have calculated. So just increase the calculated load by 10%. What is coming? The revised load is coming as your 1425 kN. Okay, so your load calculation is complete. Now from the soil test we have already got what is the safe bearing capacity. Let's assume you have a very medium clay soil, and for that very conservatively just assume 10 ton per meter square or 100 kN per meter square safe bearing capacity of your soil. Maybe for your soil it is more than that. Maybe it is 15 ton per meter square or 150 kN per meter square, or maybe less than 10 ton per meter square, say 7 ton per meter square or 70 kN per meter square. Just for example, we are assuming here that the safe bearing capacity of our soil is 100 kN per meter square. So what is the area required for your foundation? Simply you have to divide this total load by this safe bearing capacity. So what is the required area of your foundation? It is coming as 14.25 meters square. My task is complete without any software. I have already found how much area is required for my G+4 storage building. Okay, now the question is whether isolate foundation is sufficient or I have to provide the Raft foundation. Okay, let's see how I have to decide whether Raft is required or isolated foundation with this area is sufficient. Okay, for that again, how much area is designated or how much area is provided for particular this column. From this tributary area you can calculate it as 15.75 meters square. And how much area do you require for your foundation? This is 14.25. So you can say that almost 90% of your tributary area is required as your foundation slab area. So is it okay? Let's provide each of the foundation under each column. It looks like this after providing. So you can say that very few area is remaining and you decide to provide the Raft foundation. Why? You think that the shuttering cost will be more than the concrete if I provide isolated footing. Well, you are right. You have to provide the Raft foundation. Isolated footing will not work in this case. If you provide isolated footing, the whole building will sink within the soil. Okay, but your logic is not right. Your logic is just like a layman or a common man. You have to think from the engineering point of view why isolated footing is not sufficient for this case. Why you have to provide Raft foundation. Well, so you have just calculated the percentage of your slab area in terms of the tributary area. What was our tributary area? It was almost 15 meters square and required slab area was 14.25 meters square. So the percentage of the slab area was almost 90%. Now the thumb rule, or you can say it is also scientifically proved that if this percentage is more than 50%, you have to go for Raft foundation. Okay, some engineers allow this up to 60%, but my recommendation is always go for Raft if this percentage exceed your 50%. Why? Well, I am just proving it. Why 50% is the limit. Okay, so you have to provide the Raft foundation like this. Instead of providing this isolated footing, you have to provide the thorough slab like this. This is known as Raft. Okay, so now this is time to prove why if this percentage is more than 50%, you have to go for Raft foundation. So the question is if the required slab area is more than 50% of tributary area, then we have to go for Raft foundation, and it is time to prove it. Why 50%? So for that, just for a while, go back to the soil mechanics class. Consider we have provided already the isolated footing like this, all the 9 isolated footing, and we are considering a strip like this. This is the strip, okay, which is of width of only unit length, and the length is as it is. So if we cut a section here, it looks like this. These are the column and these are the foundation. Width of each isolated footing, let's say it is B, and the spacing between them, edge to edge spacing, is, say, this is S for spacing. Now you have provided your foundation at the depth of D from your ground level. What is the soil mechanics? The mechanics is when the load is coming to this column, it comes to the foundation or the footing slab and it dispersed like this. What is the angle? Normally it is considered that for 2 unit vertical depth, the horizontal dispersion is only 1 unit. In your shape bearing capacity, you consider the soil up to the depth of B or the width of your footing slab. So in our case, this is B. So for depth B, the dispersion will be B by 2. Similarly, in this side also B by 2. So you can see for B width of your slab, the required dispersed width is B by 2 plus B by 2, or total 2B. So slab area is B into 1. Why? We have already considered unit width. Okay, so slab area is B into 1 or B, and required dispersed area is 2B into 1. Okay, or you can say B plus B. Why? Because this is the B and this is B by 2, this is B by 2, or total B. Our spacing was S, so we can say also that this is S by 2, or our spacing between the slab is equal to the width of our slab. So for effective isolated footing, always the spacing between your slabs should be equal to or more than the width of your foundation slab. Now the question is, if this is slab area B and tributary area 2B, our percentage of slab area is how much? Simply B by 2B, or 50%. Okay, up to 50% we can utilize our soil up to its 100% capacity, or our building will not sink, or our isolated footing will works. Okay, now what will happen if this percentage is more than 50% or the tributary area is less than 2B? If less than 2B, only in that case this percentage will be more than 50%. Or in other words, you can say that this spacing is less than B. What will happen? Just notice. Can you see what is happening? Just observe the S. S is decreasing, and what is happening? I think it is clear to you. You can see here the soil from this point to this point was carrying the load only coming to this column, but in this case the soil from this point to this point is carrying load for this column, partly for this column and partly for this column. So obviously it cannot carry this much amount of load. This footing will simply sink. Okay, that's why you have to go for Raft foundation. And what will happen if it is Raft foundation? Well, in case of Raft foundation, the whole strip looks like this and load dispersed like is this. Obviously, there is no overlapping of load dispersed area. That's why your building will remain steady. Okay, if you find this video useful, to get more this type of video, please subscribe it.